Hello everyone, welcome back. So today we will continue our chapter Understanding Quadrilaterals. I hope you have practiced the previous topics, and if any doubt, please let me know. So let's start with our topic, that is Understanding Quadrilaterals. So today we will learn formulas for N-sided regular polygon. So I think now regular polygon is very much clear to everyone. We have done in previous class. Regular polygon means a polygon with equal sides. So whatever be the number of sides, they should be all equal to each other. That is your regular polygon. So here N will represent the number of sides. Clear? So first of all, we will learn how to find the sum of interior angles. So in previous class, we have learned to find sum of all the angles of quadrilateral, and that was 360. Okay. So today we will learn that how we can find sum of all the interior angles of any polygon with n sides. So what values n can take up? As we know that we need 3 sides to make a polygon. So n can be 3, 4, 5, 6 and so on. So let's start with this only. You already know that the angle sum of triangles is 180 degrees. So let's try to find out with this formula. Okay. So if I put here 3, this will become 3 minus 2 into 180. And 3 minus 2 is what? 1. 1 into 180, that is 180. So this is the angle sum of all the interior angles of a triangle. Clear? Let's take one more example. If I take n as 4, so 4 minus 2 multiplied by 180. So 4 minus 2 is how much? 2. 2 into 180, that is 360. So I have taken n here 4. 4 means it is a quadrilateral with 4 sides, and that too all equal. So what will be its sum of all the interior angles? 360. Clear? Now see, if we have to find each angle, each interior angle, clear? Each means one single angle. So if I take a triangle, and we know that all the sides are equal, so all the angles will also be equal. In case of equilateral triangle, we know that each angle is 60 degree. Okay, now let's apply this formula. So the sides will be what? Now see, n minus 2 into 180 is sum of all interior angles of a regular polygon. And if you divide the same by n, that is number of sides, you will get each. Clear? That is one interior angle. So let's find it out for a triangle. 3 minus 2 into 180 divided by 3. So this will become what? 180 divided by 3. Hence 60 degree. So we know that each angle of equilateral triangle will be 60 degree. Similarly, you can put here 4, 5, any, and you can find each interior angle. Okay. Now see, we have done with this in the previous video with proof that 360 is sum of all the exterior angles. Clear? Whatever type of polygon it may be, but sum of all exterior angles will be 360 only. So if it is a regular polygon, then what we will do? If you divide it by n, that is number of side, you will get each exterior angle. For example, if I divide this 360 by 4, so what will be each exterior angle? 90 degree. Clear? Now, next is number of diagonals. How to find number of diagonals of a regular polygon? Here, n is again the number of sides. So, n into n minus 3 by 2. So, if n is 3, let's find the number of diagonals in a triangle. 3 into 3 minus 3. Clear? Divided by 2. 3 minus 3 is 0. So the answer is coming to be 0. So if you observe a triangle, can you join any opposite vertex? No. Hence there is no diagonal in a triangle. Clear? So this has been proved with this formula also, that we have 0 diagonals in a triangle. Clear? Now similarly, if I take a quadrilateral, clear? If I take a quadrilateral, what will be the value of n here? 4. So first let me clear this with the help of figure. This is quadrilateral. If you join opposite vertex, you are getting two diagonals, 1 and 2. So put here 4. 4 into 4 minus 3 divided by 2. So 4 minus 3 is what? 1. So 4 divided by 2 is 2. So hence we are getting two diagonals. So all these formulas will be used to solve questions given in your exercises, right? So I hope all these formulas and the terms related to polygons are clear till here. So the golden rule is to practice every day, practice and follow for more. The next topics of this chapter will be uploaded in the next video. Thank you.